In today's data structure class, we will see the queue structure from second unit. And in this class, we will see what is queue. After that, the types of implementation. That is, we have two different types of implementation in queue. After that, we will see the representation of queue, then the different types of queues. After that, we will see the operations of queue, especially the enQueue, deQueue, isFull, isEmpty, and peak. These are some of the operations. And finally, we will see the applications of queue. First, let us see what is queue. Queue is a linear data structure in which the data are stored sequentially. Okay, so the data items will be stored sequentially, and this is called as queue. Okay, and the data insertion is done at rear end and the deletion is done at front end. Okay, for example, this is a queue and this is the front of queue. Okay, so this is front and this is back side, that is rear side, right? So the insertion will be done from this end and deletion will be done from this end. Okay, front side, and this is called as first in first out approach. That is, the element which comes first to the queue will get served first, right? So this is otherwise called as FIFO. Here, the queues are mostly used if there is a single resource and multiple users want to access those resources. Okay, so in this place we are going to provide service, and this service will be accessed by many people. Okay, so resources is single but the users are multiple. In that situation we can use queue, right? Let us see some of the example. The people waiting in a queue to buy movie tickets. This is one example, real-time example. And all CPU scheduling algorithms are implemented only by means of queue structure. Okay, so this is queue. Queue is nothing but it is a linear data structure in which insertion is taken place at rear side and deletion will be taken place at front side. So this is otherwise called as first in first out approach. When come to queue implementation, we have two types. First one is queue using arrays and second one is queue using linked list. Arrays are sequential implementation, that is the memory will be allocated sequentially for all data items. And when come to linked implementation, the memory is allocated whenever the free space is available, but all the nodes will be connected to each other. Okay, so this is the two types of implementations. Here the first one is sequential implementation. Sequential implementation is a static one. That is, it can be implemented by using array. During declaration time itself, we have to specify the number of items. Number of items in the queue, right? So this is sequential implementation. Here, the queue implementation using an array can organize only a limited number of elements. Limited number of elements. That is, during declaration itself, we have to specify the number of items in the queue. Hence, it is called as static implementation. The next one is dynamic implementation, that is linked list implementation. Here, it can be implemented by using linked list. That is, a sequence of nodes will be connected to each other, and whenever there is a free space, in that place we can store our or we can create our node. Okay, the queue implemented using linked list can organize unlimited element because dynamically, that is, if we want, we can create a node, isn't it? So this is dynamic implementation. So two types of implementation we have. One is sequential and second one is linked implementation. Next, let us see the representation of queue. Queue will be represented like this. The data item index starts from 0, 1, 2, 3 like this, etc. Okay, queue is an abstract data type, that is ADT. Here, the implementation are hidden and it shows only the abstract. Here there are two pointers. First one is front pointer, which is always point the first item in the queue, and second one is the rear pointer, which always point the last item of the queue. Okay, the front pointer, which is very much helpful in the deletion operation, because we need to delete only the first item, that is front side item in the queue. When come to rear pointer, this is helpful for the insertion operation, because insertion will be taken place only at the rear side, right? So front pointer and rear pointer are two important index we need to maintain in the queue operations. Next, the types of queues. We have four different types of queue: linear queue, circular queue, priority queue, and dequeue. In today's class, we will see the linear queue in detail, and the remaining types we will see in our forthcoming classes. The first type is linear queue. It is a simple queue in which insertion occurs at one end and deletion occurs in the another end. For example, this is queue, this is front side. The front side we can perform the deletion operation, and in the rear side we can perform insertion operation. Okay, and the drawback of this linear queue is the memory utilization efficiency is very less, because the insertion can perform only at the rear side. Okay, insertion will be taken place only at the rear side. See, after deleting the data items here, we can have free memory space. But this memory space cannot be utilized properly when come to linear queue, right? The next one is operations of queue. The basic operations are enQueue, deQueue, initialize, isFull, isEmpty, front and rear. Here enQueue is the process of adding an element or inserting an element to end of the queue is called as enQueue. And next one is deQueue. deQueue is nothing but removing or deleting an element from the front of the queue, front side of the queue. Okay, and next one is initialize, which is used to create an empty queue. And isFull, this is a function is used to check whether the queue is full or not. And the next one is isEmpty, which is used to check whether the queue is empty or not. And next one is front. So this return the element at front end without removing it. Simply that will display the front element of the queue. And rear is that will return the element at rear end. That is, the last item of the queue will be displayed without removing it. So these are some of the basic operations. Let us see those operations in detail. The first one is enQueue operation. enQueue operation means inserting a new item into the queue, right? So before inserting any new item, the first step is whether queue is full or not. First we need to check the queue is full or not. If the queue is full, then print overflow error and exit from the program, because the queue is already full, then we cannot add any new item. Okay, and third one is, if the queue is not full, first increment the rear pointer to the next empty space. Okay, see, this is our rear pointer to be incremented by next space or incremented by 1, and add the element to the position pointed by the rear. So here we need to add the new data item and return success. Okay, the time complexity of enQueue is order of 1. And this is the pseudocode for the enQueue operation. This is procedure enQueue data. If queue is full, then return overflow error. Else, if rar equal to rar plus 1, queue of rar equal to data, and return true. Okay, this is the pseudocode for enQueue operation. The next one is dequeue operation. The opposite to enQueue is dequeue operation. Here we are deleting an existing item from the queue. The first step is check whether the queue is empty or not. If the queue is already empty, then we cannot delete an item. Delete is not possible, right? If queue is empty, then print underflow error, then exit the program. You cannot delete, right? Otherwise, if the queue is not empty, then access the data where the front is pointing. See, access the data where the front is pointing. Front is pointing here. And increment the front pointer, point to the next available data item. So the front will be incremented by 1, right? And return success. So this is what dequeue operation. And this is the pseudocode for dequeue operation, procedure dequeue. If queue is empty, then return underflow. We cannot delete, right? Else, if else means if data are available in the queue. If data equal to dequeue of front, next front will be incremented by 1. Front will be incremented by 1, then return true. That is delete item succeeded, end procedure. So this is what the pseudocode of dequeue operation. The next one is isFull operation. IsFull operation, which is used to check whether the queue is full or not. Okay, that is the rar pointer reach the maximum size or not. Okay, whenever rar points to the maximum size of the queue, then the isFull operation returns true value. That means isFull is a Boolean operation. Boolean operation means it will return either true or false. If the rar reaches the maximum size, then this will return true. Otherwise, if the rar is pointing somewhere else, then it will return false. Okay, so this is the pseudocode for isFull function, Boolean, because it is a Boolean operation. So the return type is bool. Boolean is full if rar equal to size minus 1. Why size minus 1? Because index starts from 0, 0, 1, 2, etc. Okay, hence the maximum size, for example, 10 means the size minus 1 is 9. If the rar reaches 9, then it will return true. Otherwise, it will return false. The next one is isEmpty operation. IsEmpty operation is used to check whether the queue is empty or not. Okay, it is also a Boolean operation, hence it will return either true or false. Okay, if the front pointer is minimum or it pointing to an invalid index, normally minus 1, this is the first condition. For example, this is queue. Initially, the front equal to minus 1. Okay, because the index starts from 0, right? So if it is minus 1 or any of the minimum value, or the second one, front is greater than rar. After deleting, the front will get incremented, right? So if the rar point is less than front pointer, then we can declare the queue is empty. Okay, if the queue is empty, then it will return true value. Okay, and this is the pseudocode for the isEmpty function. So the return type is bool isEmpty function if front less than 0. If front value is less than 0 or front greater than rar. Okay, then it will return true. Otherwise, it will return false. Means some of the items there in the queue, right? So this is empty operation. The next one is peak operation. Peak operation, this will return the data item which is available in the front of the queue, because the peak item to be deleted, right? So it will return the front item in the queue without deleting it. And into peak. Into peak means the return type. The front item, queue of front will be returned here. Okay. See, for example, if it is A, B, C, D, then the front is A. Okay. We simply display the A, not deleting the A. Next, let us see the applications of queue. The first one is multiple users for single resource. Okay, whenever the process or try to access a single shared resource, then we can wait those process inside the queue until it gets served. Okay, for example, printers, that is shared printer inside the office, CPU, more number of processes try to access the CPU, and these are shared resources. Here, the process will wait inside the queue. Okay, this is the first application. And second one, asynchronous data transfer. Asynchronous data transfer means the rate of data transmission is different from two processes. That is, this is one process and this is another process, second process. Here, the transfer rate from one process to another process is different. Okay, and the number of transmission is also different. For example, queues are used in pipes, file input and file output, sockets of asynchronous data transfer. So in this area, we can use. And the third one is queues are used as a buffers, and it is very much helpful as a buffer to store data primarily whenever required. So the temporary storage of the data items. Okay. See, the data will be stored inside the queue. For example, MP3 players, CD players, the data will be temporarily stored in the queue until it will get accessed. And the fourth one is interrupt handling. This is very important application of queue. Whenever the process get interrupted, okay, for example, CPU is here, the process are waiting in the queue, and when it got interrupted, then the process will go back to the queue again, okay, and sent back and made wait in the queue, right? So this is interrupt handling. And the last one is maintaining playlist. Queue helps to maintain any kinds of list, any kind of list. We can maintain the playlist of songs and other media files. For this, we can use the queues. So far, we have seen the queue data structure from the second unit. Here we have seen what is queue and the different types of implementation, that is array implementation and a linked list implementation. After that, the queue representation and different types of queues we have seen, and operations of queue, that is enQueue, deQueue, isFull, isEmpty and peak. After that, we have seen the applications of queue. In the next class, we will see another type of queue from the second unit. Thank you.